Hi, my name is Ajay, and this is Lab 2 Modern, or Lab 3 for Modern Physics 2. This one is the bar magnet lab. So in this experiment, we're going to be measuring the distance dependence of the magnetic field due to a bar magnet. We also want to cover the difference between actual and predicted results to calculate, or to see how correct our measurements were just based off of the setup of our experiment. And we're going to be using GlowScript to do the modeling. So from this result, the magnetic dipole is equal to 1.27, and the slope of our distance-dependent equation is negative 2.437. And then we have our observed magnetic fields, which you can see below, which is from our calculations and measurements just from the experiment. And then the predicted by the script magnetic field is also listed, done from calculations and magnitudes from the experiment itself plugged into the code script or the live script. So here are some physics concepts we're going to be covering. We're going to be covering the Biot-Savart law, magnetic fields, magnetic dipoles, and the distance-dependent equations, all just really relating magnetic field and magnetic dipoles, and using that to, in our situation, to calculate the magnetic field based off of distance and on-axis versus off-axis locations relative to the bar magnet, and then also use the distance-dependent equation to calculate the magnitude of our dipole from the data we recovered during the physical lab experiment. So for the experiment, our system will be the bar magnet, and then surroundings is the Earth and the objects in the room. Objects in the room is important for our error later on. And the initial conditions, the bar magnet at the end of the meter stick, that's just our initial condition. Ideally, there's no other forces other than that acting on the given observation point. And then for the procedure, we're going to record measurements both on axis and perpendicular measurements. That way we can calculate the 45-degree angle measurement. So for this experiment, I gathered these results from the lab itself, or from the experiment itself, and all the numbers can be seen there. Some of these numbers were used to calculate the magnitude of the dipole, but we also calculated these results from live script, or this live script. So here's the code used to predict the magnetic field. And then here's our result. So our distance dependence equation is equal to y is equal to negative 2.4373 x minus 13.638, where n is our slope, k is equal to our slope intercept to the power of e, or e to the power of our sloped intercept, as ln k is equal to our intercept, and then mu from the equations mentioned in our physics concept slide is equal to 1.27. And then from this, we can see that our distance is equal to 4.4899 e to the negative 6 and 1.3698 e to the negative 5, a lot different than our actual recorded magnetic field. So here's some assumptions that we made. We made an assumption that the bar magnet has magnetic dipole and is in the same direction of its magnetic fields. This is important for just the signs in different measurements. And the only recorded magnetic field was from the magnet in the Earth. Also, we made the assumption that our magnetic field is approximately 49 nanoteslas in Atlanta. But with sources of error, our measuring motion wasn't precise. I noticed that I was getting a little bit off when I was actually measuring up and down an axis, and magnetic north may have had an effect on it if I accidentally tilted the phone one way or another. And also technology or table interference. The table was made of graphite, and computers and iPads were around, so that might have affected the magnetic pole. And also, what if you hadn't oriented your experiment to compensate for magnetic north and had instead laid out your meter stick a different way? So the measurements wouldn't have been accurate at all because north would have factored in both an x and y, and you'd really have to sit through and see the angle and sort out the data, but it would be less in magnitude, or yeah, it would be less in magnitude. And then what if you had two sticks identical end to end together? How would it affect our measurements? I would expect the results to be larger and in the same direction, but not quite double the original measurements. Thank you.